Well, welcome everybody. Today we're going to do the first part. This is the Ready to Fly workshop, RTF, and that's what it stands for, Ready to Fly. And that's our first workshop where we're really going to talk about, hey, let's buy a drone. We don't have anything. Let's buy something, a drone or a racing quadcopter, and let's get into this thing called FPV. So that's really what we're covering here today. There's two parts. There's the first part, which is introductions about who we are and what we do, and then very importantly, what is FPV? Because, this is why we're here. It's really, this isn't so much a drone, it's more a what is FPV, and this is what is it? And then, just talking generally about what is this session about. And then again, just looking at a few multi-rotors and such, and then going from there into the actual presentation. And this one is learning to fly, and this where and what to buy, where can I fly safely, flying a multi-rotor, the real basics of it, and then moving into FPV and FPV Racing. So this is not an advanced course. This is really a very simple course just for the beginner so that they can start in FPV and get going on that. So who we are, my name is Vivian Van Zel. I am a director in the DRC, and we have today Todd from the DRC, and he's the founder. And the DRC is the Drone Racing Club. I don't know, Todd, do you want to say a few words on the DRC?
Sure. So the Drone Racing Club was established to allow like-minded individuals to get together and really cultivate and enjoy the sport of FPV racing or flying in general, really. So what we try to do is organize events that both novice and advanced and professional level folks can gather, trade stories and ideas and concepts about the technology and the tools in the technology, as well as apply those ideas and concepts into action by putting on these events. Additionally, we're a firm believer that FPV racing as a sport has the right elements for education to infuse something of this sort into the STEM-based educational system for high school and colleges, yet be a cool sport that the jocks and the adrenaline junkies and the geeks and the nerds can all come together and have a good time. So with that, Viv, please.
Thanks, Todd. So that's Todd, and that's the DRC Drone Racing Club based out of Atlanta. So then the first question comes up, what is FPV and why we keep talking about this thing? And FPV is first-person view, and drone racing combines several technologies such as a drone, multi-rotor, is a more acceptable word, we would say, a helicopter or fixed-wing plane, and remote control, live video, microcontrollers, and a variety of sensors. It turns all of that into an experience, or that somebody like the operator of a drone will experience when he's flying it. So it builds on all of these technologies and, essentially creates a situation where a pilot is inside, literally has a point of view of a cockpit. So what do? We, of course we can fly high and do all sorts of crazy things, and drones are definitely in the news nowadays for that kind of thing. But, what we are specifically about is a drone racing, and we do close proximity to the ground, usually below the tree line, less than 100 feet. So, and our, let's call it part of FPV, we are real drone racers. We don't fly 6,000 feet in the air. We don't, we typically race and very close to the ground, very close proximity, around trees, around race courses. That is, a couple of 100 feet wide and long. We're not into, flying at 6,000 feet and giving the other air traffic trouble. So that's really what we are about. And so this session here, we're really going to talk about learning a little bit about multi-rotors and then getting you into FPV and multi-rotor and showing you where to fly it and how to fly it safely, somewhere safely. And that's a very key word for us, is this word safely, because we really want to be safe and we want to participate, with all and work with all laws and try and, keep this as safe as we can. And as you'll see, we can actually do that. Then, just again, what is a multi-copter or multi-rotor? Typically call it a multi-rotor. This is a quadcopter. What is a quadcopter? Quad meaning four, typically has 4 motors and propellers. What is a hexacopter? Well, that has 6. That is what a hex stands for. And then there's an octocopter, which is 8, and so we carry on. So, and multi-copters or multi-rotors have different, the amount of motors and propellers determines what it is, or its general name. But they're all multi-rotors, meaning they have more than one rotor. So you get a quadcopter, you get a hexacopter. Each one has a very specific task, or is better at stuff than the other. A hexacopter is maybe, an octocopter is maybe great for filming, while a quadcopter is more a general use racing type. And then we get into the sizes. These can size a copter like this, a multi-rotor quadcopter like this, because it has 4 motors. Will measure from one motor to the other 180 millimeters. So that's a small little guy. And then you go up to a guy like this, which will measure 330 millimeter, which is almost double what that guy, the size. And then it goes up from there. I mean, we get quadcopters that's the size of a screen. And hexacopters and octocopters, that's that size. But our genre, typically, this is about as big as we'll go. We'll start at the 180 and work up to about the 250 size. So that's just generally what the sizes are about. So, of course, in our next presentation, the DIY workshop, we go into a lot more detail about this, but this is, just generally talking about this. So let's move into where to buy a drone. Where do I start? If I wanted to buy a guy like that, which is a DJI Phantom, where do I go and get those? So there's 3 categories as I see them. There's the specialty store, like Atlanta Hobby or Grayson Hobby. And these guys are specialty stores, local stores. You can go buy a DJI Phantom from them. If you have any problem, you go back and you ask them, and they'll fix it for you. And they build up a relationship with you, and they can even build you stuff. So that's one. Then the next group is maybe Fry's and Target and those guys. Basically, you go in there, you buy a drone or a quad, and you go look on the internet on how to work it or how to maintain it. I mean, it has warranties and that kind of thing, but it's very basic. And then the last group is maybe online, getfpv.com, hobbyking.com, Amazon, eBay. Everybody now sells a drone. You can virtually buy it anywhere. But of course, these are all online stores. And if you have a problem or you need questions answered, they are going to help you on a forum or something like that. And return, you'll have to send it back to them. Hobby King is Chinese based or Japanese based, Eastern based. So you'll have to send it there. They do have some US stores, same with Amazon and eBay. So that's where you get a drone. So then, what kind of drone do you want to get? And that's the question. So they come in various, what we'll call maybe classes or classifications or something like that. You'll get RTF, ready to fly. You get everything. So if you don't have anything and you're starting out absolutely from scratch, this is what you want. You want the RTF kit, meaning ready to fly. You take it out the box, you plug in the battery, and you'll get everything you need. And we'll talk about what everything means. And then you get an ARF almost ready to fly. It's almost. So in some cases, you might have to add a controller or something. That's typically a bind and fly. In some cases, you might have to do some assembly, and that's what a almost ready to fly is. So it's close to a ready to fly, but it might be some assembly required or one or two pieces missing. Then a bind and fly is typically, you already have this thing called a radio and a receiver, and you already have some other quadcopters maybe or other RC equipment, and you're going to put your little receiver inside the copter, and you're going to bind your radio to it. So it has everything except for maybe the control system. And then the workshop after this is the DIY workshop. That's doing it yourself. That's actually buying a quadcopter parts, like and building something similar to this, meaning totally building a quadcopter from scratch, and that's called a DIY quadcopter. This guy over here is a very small example, and this is called a Ladybird V2, and it is actually a RTF, meaning you buy the quadcopter, you get the battery with, you get the radio with, and you get even a FPV monitor with, in this case. So this quadcopter here is typically a ready-to-fly kit. Something like this one is more a, I'm going to go build something from scratch. Okay, so if you don't have anything, that's the place to start, RTF. My suggestion, and this was my path of getting to a racing drone, is starting with something like this. It's called a Hubsan X4, or one of these, a Ladybird QR, without FPV even. And that guy you can fly in your living room and get an idea of what this is all about. Can you even fly something? Are you interested in flying? I mean, you can use this guy to hop from couch to couch, get the thing, irritate the pets. It's great. And you can hit walls and fly into people, and nothing's going to happen. You're probably going to replace props on there. It's going to cost you $1 for 4 props. You hardly ever even break it. This is what you really want to start if you have nothing.
Cheap.
And it's cheap. You know, this guy is $30, $40 at the most. You can even get them cheaper than that to start off. Then the step up from that is the same concept, and that's what this one is, the Ladybird, is really a small quadcopter like that with a camera built in and a FPV monitor. So that gets you into FPV. Now you're still on a small copter, you have FPV, you have an FPV monitor. This guy sells in a kit for about $115, $120. You can, and so does the Ladybird. And that will get you into FPV. You know, you can actually plug, if you have goggles later, you can plug that in there, or you can plug a big TV in there. It has the video output. So this guy is a nice step. So $50, $150, you're all set, and you can get into the FPV thing. And then the last step, if you're going to go ready to fly, meaning buying something or a bind and fly, then it would be something like this, and that's called the Immersion RC Vortex, and that runs about $500, I think, $450, $500. So once you've passed the absolute basic, you like the FPV idea, then you make the investment into this kind of gun. And I see lots of guys jump straight into this, you've got to be pretty dedicated to go straight into there. And, you know, this guy, you're not flying it inside your house. If you hit a pet, or people, you're gonna hurt somebody. So this, I do not suggest, if you've never flown anything and you start anywhere, do not go out and buy yourself a racing vortex and say, I'm gonna learn how to fly. I would really start from here. It's $50 extra, and you know, and you've got a good direction. So, and beyond this, of course, there is building your own DIY type copter like this. Meaning, and now you can, you know, you don't have to buy off-the-shelf stuff. You can really build what you want and what you think is good. So, and there's many versions of that. Here's I brought mine today, another version. There's something small I have, and again, the sky is the limit on that.
Which one is that one?
This is a FMQ Hoku. Hoku is a 220 millimeter FMQ Hoku. So, so that's about buying drones. So really, I suggest an upgrade path like this rather than that. Of course, lots of people jump in this side, but they jump in with something like a DJI Phantom, which is great. But you know, we're not into a huge filming. We're talking specifically in this about FPV racing quadcopter. You can jump in this side with a filming platform, of course you can, but that's not FPV and that's not racing. So this is a good way to get into FPV racing. So the safety aspect. I'm not going to talk a lot about what's legal and what's not, because it's a gray area and it's a never-ending. But here's a nice site that will give you, and you can drill in and put your address and look where you are, and it's going to draw little red circles around areas you shouldn't fly. And typically, where you shouldn't fly is currently in the US, national parks, military bases, or 5-mile radius around the airport. You shouldn't fly there. This map will show you that. It'll show you where the parks are, it'll show you the military bases, and it'll show you where the airports are and draw around it, you know, a circle around it. So that's a good reference. So don't fly it. So what does the law say? The law is very gray, and I'm just going to touch on this, but it basically says if you want to fly what is UAV?
Unmanned aerial vehicle.
It just hit blank. Sorry, unmanned aerial vehicle. With an FAA controlled space, you need to ask for approval. You will never get it, but you need to ask for it. So if you want to use it for commercial purposes, you need to ask the FAA. You will have to do a lot of things to get that. We're not into any one of these two. Again, we're flying at 100 feet off the ground. We're not flying in controlled airspace, and we're definitely not doing this for commercial purposes. So, but this one is pretty important. Keep your aircraft within visual range and under complete observation at all times and below 400 feet. So, and definitely we fit there. There's a controversy about what's FPV. Our club or group we belong to is the AMA, and they say a spotter is good enough to have eyes on the copter for you. The law is gray. Is it okay if somebody looks at it, or does it have to be you? We don't know. These things are changing, and I'm not, you know, I don't really want to go deeper into that. It's just a deep hole. So, flying a multi-rotor, the basics. So, what are the basic parts? Somebody who just buys a multi-rotor, what are the basic parts? He looks at the propellers, and note that every propeller has a direction. Some spin clockwise, some spin anti-clockwise. On a typical quad like this, on one like this, these two would spin clockwise, and these two would spin anti-clockwise. And you'll note that on the propellers, there's typically noted a R for reverse, meaning these propellers, the two anti-clockwise, should have a R on them. So it's important if you mount your propellers to mount it the right way. Know that they are actually two different propellers, clockwise and anti-clockwise. So that's the first thing. Second thing is look at your motors. They should be clean and clear, meaning if you spin a motor like this before you take off, you should be able to spin it. It shouldn't get caught on stuff and be stuck with stuff. So that's important. Then the third thing is your battery. And batteries vary in sizes. Here's for the little quadcopter size battery. A bigger guy would use a battery like that. A DJI would have a huge battery. Here's another example of a battery. And charging these batteries are very important. And charging them safely is very important. You know, always use the designated charger. Always do not leave them unattended when you're charging. These are actually, if you puncture them or something, they are little bombs. And you don't want to read the guidelines very carefully before charging. But that's the next thing you need, and make sure that, of course, your battery is charged. And then the next thing you need is a radio, and there's many kinds of radios. Here's my radio, and it's called the Devo 4, and I'll show you what the 4 stands for. Here's another example of a radio. That's a Devo 7. That has 7 channels, and it has a equipped monitor, a FPV monitor. This smaller one also has a equipped FPV monitor. It actually flips up like that, and there's a little monitor inside there. So, but yeah, that's the radio. And with this guy, the radio, you're actually going to control the quadcopter. That's what the radio is for, and you're going to tell it what you want it to do. And then the last piece is your camera, FPV camera, and your goggles or monitor. There's you can of course choose. Some people prefer screens or monitors. There's definitely a case to be made for both. Screens and monitors are usually nice because you know what's going on around you. You can still look around. Goggles are much more immersive. But some people just can't do monitors. They just don't like monitors because it's too immersive. It really is up to you. So that's a bit about before you go fly. And just a quick glance over what's the technology about. How does a multi-rotor fly forward, and how does it stay level? So if you were to look at a small multi-rotor like this guy, and I'm just going to move some stuff out the way. Yeah, there we go. If you look at a small multi-rotor like this, if you were to if it were to just hover above the ground like this, all 4 propellers would most likely be spinning at the same speed, meaning it would stay exactly like that. If we wanted this to move forward, we will instruct the computer inside here via our radio to speed up the 2 propellers at the back. Your instruction really is just move forward. What happens in reality is the 2 back propellers would speed up and the copter would start moving forward or backwards or left or right, whichever way you want it to move. So inside here is a little computer that controls all 4 of these propellers and acts on your command. The other thing, of course, is there's magnetometers and barometers and accelerometers. A lot of computer stuff in there that tells, if a wind were to come to start blowing the quadcopter to the right, a computer inside will say, hang on, let's level the copter again by giving more throttle on this side, and you don't even have to do anything. The computer inside the quadcopter will do that for you. And that's why quadcopters are very easy to fly. You know, at its very basic, you will give throttle, it will go into the air and hang there. And now the instruction says, am I going to go forward, back, left, or right? So very simple to fly. Then the radios, we spoke about the channels. I'll show you the channels in a few seconds. Lots of these quadcopters have things on like GPSs, and that's in racing, typically no quadcopter has a GPS in, and that just tells, you know, the copter where it is, and that ties into fail-safe return to home and return to launch. Some of the big quadcopters, I can hit a button on my controller and say, please come home, and the copter will take care of flying back to you. But for that, of course, it needs this thing called the GPS to know where it is and where it took off from, so it can come back to you, return to launch. But and typical in our racing world, with us flying a few hundred feet away from us, this has no use for us. We have no use for a GPS. We have no use. Our ranges, you know, our ranges for what we typically build a racing quadcopter for is a few hundred feet. But these ranges can go up to 30 miles. We don't build racing quadcopters like that. What is important is this thing called fail-safe, and that is very important to us, so that if anything were to go wrong with our quadcopter, we would lose connection or our radio would stop functioning. Our copter needs to be set to fail-safe, and because we don't have GPSs and all of that on, fail-safe to us typically means a controlled descent or even a throttle cut, so that it just falls on the ground and doesn't fly away or do anything crazy. So, and again, that ties in with safety. I'm very big on controlled descent, meaning I can set fail-safe so that if the radio connection is lost, the copter goes to a slow descent and lands. You know, there's lots of people that will argue it's better that it just falls from the sky. I say it depends on where you're flying. If you're flying near people, I wouldn't want it to just fall out of the sky. I would prefer it to descend, but you know, that's really up to you. So, how do I fly this thing? There's really just four basic things, and that's where the channels come in. These the absolute basic means you have four channels. Channel number one is this guy, or it's not really, it's typically channel 3, but the first one we're worried about is throttle, and this is called a mode 2 radio. Now, mode 2 radio is meaning the throttle is on the left-hand stick. So if I move this thing up, the propellers are going to start spinning faster. Remember, some are clockwise, some are anti-clockwise. Going to start spinning faster, and this thing's going to take off and lift into the air. That's the first thing that you can do, and that's with this stick on the left, you push it up or down, and that controls the throttle. And that really just controls the speed of the rotors or the propellers. The second thing you can do is called yaw, and it's also on the left-hand stick. And with that, if you were to hit or move a yaw stick, the copter would yaw, meaning left or right turn. Maybe another word for it is turning left or turning right. It wouldn't pitch, it wouldn't do anything, it would just simply turn left and turn right. So that's the second one command we can give it, or the second channel. Then, and that's with this left-hand stick moving it left and right. Throttle was up and down, yaw was left and right. The third one we have is this thing called pitch, and that's with the right-hand stick. You can pitch forward or pitch backwards, and if you look at a copter, again, it's something like, if I were to pitch forward, it would do this number like explained, and the copter would start moving forward, or if I were to pitch back, the copter would start moving backwards. So that's the pitch. And then the last essential channel is called, oops, I skipped that. The last essential channel is called the roll, and that's the right hand stick, left and right, and not up and down, left and right. And with that, what we're really going to do is give a copter the ability to roll, meaning roll left, roll right. So, and that's the 4 basic movements: throttle, up and down, yaw, turning left or right, pitch, moving forwards or moving backwards, yaw, move left or move right. Oh, so roll, I'm sorry. Yaw, pitch, roll. So if I were to roll left, the copter would start moving towards the left, or roll right, pitch forward, pitch backwards, yaw, and throttle. And that's really just the 4 channels, and those are called the 4 essential channels to fly a quadcopter. Once you can do that, you can fly. Now there's, like I showed you the earlier radio, that has 7 channels, and that's where you can start adding things like, I want to change the mode of a quadcopter. That's another channel you can use. Or meaning I want it to be more aggressive and act faster, or I want it to return home. You can assign, in a bigger Devo 7 here with 7 channels. You'll see that it has little switches. So I can say, you know what, when I hit this switch, I want it to come back to me. Yeah, it's called return to home. You can assign it to 1 channel. And racing quadcopters, though, that is not very big, as we don't, typically have anything return home or so. So we typically...
Sometimes we wish to.
Yeah, and typically we at the minimum, I would say, you need the 4 basics, else you can't fly. But you need a 5th one maybe to change your mode or your aggressiveness. How you're flying. That's typically 5 minimum. Okay, so that's on flying a quadcopter. It's fairly easy. It's really simple. I can try and show you something. Let's see if I can actually show these commands to you in a few seconds here. Oh, sorry. Back. There is my radio. It is now bound to my quadcopter. And first one is throttle, the left stick. And you will see that the quadcopter basically just lifts in the air. Then there's the yaw, which you'll see I'm yawing left at the moment, or I'm yawing right. You'll see it move left or right. And then, of course, the pitch and and the roll. There I'm moving left or right. So that's the basic idea of how a quadcopter flies. And I'm going to just quickly fly it around the room here. You will see, there it is. I can let go basically off the controls, and it will just hang there. And I can go forwards, backwards, left, right, or turn, and that's called yaw. So the basic idea of how to fly a quadcopter. So the next thing we're looking at is FPV. So what's FPV, and where does FPV come into? Now that we have a quadcopter, we can sort of fly it. What does FPV do for us? So FPV does this thing. Quadcopter typically has a camera inside. The camera view as a certain angle. So like any other camera, you'll see something in a view. But instead of the data just staying here, it will transfer that view in real time to whatever viewing device you have there. So like in my case, I have a little quadcopter with a built-in monitor. So whatever the camera sees, I will see in a monitor. Or you can use goggles, meaning whatever the camera sees will end up on the display. So what's important in our world and with this is this thing called latency. So an FPV, you know, of course, a Phantom, you can put a huge camera on there with super high definition, but the amount of data that the computer has to process and transfer and display would be way too much. And that's where latency comes in. So our resolution, as it's known, here is typically pretty low. It's like 480 TVL, you know, or not even TVL. TVL is it's 480 lines, yeah. 700 or 600 TVL. So it's pretty low, and the reason for that is there's a lot of information we want to get from here, the camera seeing it, to you viewing it in your goggles or on the screen almost immediately. What you don't want is to fly, you know, towards the wall and only know that there's a wall 2 seconds later. You know, you know, by then you've already hit the wall. So you can see that it's absolutely essential to get the data from the camera to you very quickly. And you know, once you do high definition, there's a lot of processing and a lot of bandwidth involved to get you that data. So a lot of FPV systems do have these things. They even do it on tablets. You can view, you know, you're on a tablet, but there is a second or two latency, meaning, you know, it's fine if you're going to hang above a monument or over a river and you want to take a video. If you're doing FPV racing, though, and racing quadcopters, you cannot do that. Even a second delay is way too much. You need information much quicker. So how that practically looks on a little quadcopter like this is, I'm going to try and show you quickly here. There is the copter, and here's the little monitor for it. And you will see the start, and you will see, there you are, there we go. And you will see the view that the camera is viewing. So there's the camera viewing itself, and you will see the view is almost immediate. You will get the view out of the camera. So what happens in this instance is the view or the data travels in through the camera, out through the antenna, FPV antenna, into the radio or FPV monitor, and it's displayed to you over here. Now again, you can use something like goggles, which look like this. And in that case, the monitor is actually two little viewing monitors inside there. Or you can use a bigger monitor like this, and you'll also get the display. So there's various sizes and ways to view it, but the main idea is the data that travels in via the camera, you will view on the monitor. So that is really what FPV is. How do I fly FPV? So people will say, now how do I start flying FPV? I can now fly a quadcopter, but how do I actually fly this thing? So don't try FPV unless you have a small quadcopter like this. If you have anything of any decent size, get yourself a spotter or a person that will help you. And there's two exercises you can do. This exercise, basically, you're going to go into a hover about 6 feet or 8 feet off the ground, and you're going to have your spotter walk in a half moon in front of you, and you are going to yaw, meaning you're going to turn your copter left or right. Let's show yaw again. You're going to turn the copter left or right and try and follow him. So your spotter is going to walk from here to here, and you're going to yaw, and you're going to yaw to keep him in view. And that will teach you first of all, throttle control to keep your quadcopter a certain distance off the ground. And you'll know it's a certain distance off the ground because you'll be viewing distance, and with the spotter in view, you'll have some context of what 6 feet or something like that's about, how high that is about. So, and the other thing it's going to teach you to do give you good distance and orientation. So that's the first exercise you can do, and that really gives you a good, idea of what's going, a good exercise to start with. And then the second exercise you can do is this one, where your spotter really, it's about a 200 or 300 feet open area. You're going to follow him while he walks around a set point or a tree or a pole or whatever you want to put there, a cone, walks around and walks back and around here, and you're going to try and follow this guy. So this again is going to teach you throttle controls, again going to teach you if you go around the ends. It's going to give you distance orientation, but it's also going to teach you pitch and roll, because to turn around here you actually have to go around, but you also have to pitch to go forward and roll to go right. So it's going to combine everything you need. So it's really just round the pole, around the area with your spotter. Now later, of course your spotter can leave and you will do this on your own without the spotter. You can fly between, and maybe a figure of 8 is a good way to start. So that's how you would start flying quadcopters and or FPV specifically. And this isn't line of sight. Line of sight meaning you are looking physically at the quadcopter. These exercises are specifically for FPV, meaning you at this point are viewing this person via the camera and your goggles. You are not, looking at him, and you're viewing him via the FPV monitor. And then lastly is FPV Racing. Once you progress from there, you will do what we have outside, which is a FPV race. And there's a set course with gates and flags you will follow. There's typically 1 to 6 races that will start with you and follow the course under the gate, round the flag, round this flag, round that flag, under that gate, round, back to start and finish. Everything is timed. If you miss a gate, you've got to come back and fly under it again. Make sure you get around the flag. That's typically the rules. And time is very important, but finishing is almost more important. That is really a very... we got a lot of guys who jump off and hit the first flag they can find, and that's the end of the race. And then, slow and steady wins the race. So that is basically what we have outside there, this FPV Racing. And these are guys who's now learned the previous 2 movements. They could yaw and they could fly around 2 points or maybe 2 trees. And now they've taken it to the next level and they are actually now following the course. But again, this is all viewing it via the goggles or viewing it via FPV monitor. So that is FPV Racing, and where to start and where to go. So do we have any questions?
Do racing drones have fail-safe or GPS typically?
Racing drones typically only have fail-safe, but and that is optional, but no GPS, because again, a drone, you're flying within 200 feet of you. If you can't find it in 200 feet, and believe me, it's possible not to find it within 200 feet, but you do not need GPS to have it return to you or tell you where it is.
Do racing drones have to have auto level, or do they have to have auto level? I hear that some racers don't use that.
Yeah, auto level, of course, it's nice to start off on auto level, but once you're a racer, you do not want the computer to interfere with your instructions. And at that point, you're going to go into what's known as acro rate mode, and you are really going to control about, I'd say, 70% of a car. There's still a 30%, which the computer will do for you, but that level really comes down from the computer doing 80% of the work to the computer only doing 30% of the work.
Why is there mode 1 and mode 2 for controllers?
Well, it's really, the US typically flies mode 2. That's by far the most important here. I do not know the specific reason for the 2, but it's like VHS and Betamax, I guess. These are the two standards. We in the US typically fly mode 2, but there's no reason why you don't fly mode.
Is it because Americans are left-handed and foreigners are all right-handed?
No, that's not the reason.
What is better, a monitor or goggles?
And it's up to the user. I prefer goggles because I like the immersive feeling. I'm very intense and I need to focus exactly what's going on. Other people can take a monitor and do exactly the same thing. If I look at a monitor, I can only speak for myself. If I look at a monitor and I see somebody walking past, I'm done. You know, I can't take it. You know, I need to be really focused and cut off from the world when I'm flying. Where other people prefer a monitor, and they can do it.
Let's see here. I guess that's it. That's good enough.
Excellent stuff, man. Thank you very much. Thank you, Todd, for helping again today. Thank you, everybody, and we'll do our DIY workshop next. Thank you.